Okay, we're recording now, so don't say anything bad about the teacher, or I kill you. Right, the first one. Hey, it's important, listen. The first one, I've got our electrolysis set up today like this. So you don't get confused, the red wire goes to the positive terminal of the power pack, and the black wire goes to the negative terminal. You do, of course, know that there's no difference between those wires, other than the colour of the coating on the outside. But to make things simpler for us today, since that's a convention that's used for terminals, we'll use that convention, okay? So into this rather large preserving jam jar type thing, I'm going to pour some copper sulfate solution, which is our electrolyte. Yes, it's also known as blue Powerade. In fact, blue Powerade is probably less harmful. This is poisonous, so what does that make blue Powerade? Okay, so apart from some residue of previous electrolysis, which you see is now floating around in there, okay, we have inside here a solution of copper sulfate. I'm using 2 graphite electrodes, okay? 2 graphite electrodes. Okay, I'm going to turn that on, okay, and we're looking for evidence of reactions. Now, we can zoom in, I think. We have the technology to zoom in, particularly on that left-hand electrode. Can you see? Okay, bubbles being produced on the electrode which is attached to the red wire. So that is the positive terminal. Have you got chewing gum in your mouth? There are 2 choices. 1, put it in the bin, or 2... No. 2 would be I knock out all your teeth, so you can't chew it. Right, so gas is being produced there. Over at the other electrode, we can see a coating being formed. Right, it's. I can get any closer. Going to focus for me. Doesn't want to focus. I think it's trying to focus on the wire in front. That's the trouble. Okay, that coating that's forming on there is a brown colour. You can't really see on the screen, but close up here I think you can. And if I lift it out of the solution, you might be able to see it more clearly. Certainly if I put it in the view of the camera. Okay, there is a brown coating formed on there, okay? Yeah, it looks pretty dark. It's got probably got some charcoal stuff in it as well. Okay, so a gas produced at the positive electrode and a brown coating forming on the negative electrode. Okay, now that gas has no obvious smell, all right, and it's not possible for us to identify it unless we collect some and test it. What I'm going to do now is I'm going to pour into that mixture, because the sulfate anions in here, sulfate anion doesn't do anything. I'm going to pour some salt solution in there. This is ordinary sodium chloride, ordinary table salt. Made it quite strong, quite concentrated, as you can see from, yeah, some of it's not even dissolved, okay? So what I'm doing is effectively adding some chloride ions in here to see if something will happen with chloride ions. Okay, so you'd be guessing that something is going to happen with the chloride ions. Oh, yeah. I don't think we'll necessarily see a change in what you see, but another observation will be made which may allow us to identify something else produced, if you know what I mean. Okay, so now I've got a mixture of, if you like, copper sulfate plus sodium chloride. So effectively I've got copper chloride. Now,
what's happening on the other side?
Yeah, we're getting bubbling at both electrodes now. Okay, so there's bubbling occurring there.
Can you zoom out?
And you can clearly see bubbling occurring there.
Is there more bubbles on that one?
Sorry?
More bubbles on that one?
I don't know.
Negative. There's a lot.
Could be. Yeah, it's pretty much. Yes. Oh, it's a wonderful smell. And the other thing, and I'll get a couple of volunteers. I'd get Travis, but he's not here. That's a clue as to what you might smell.
Chlorine.
Chlorine, yeah. Do you want to stick your nose in there and see if you... Do you know what chlorine smells like?
Yeah.
Good. Well, you get in there and be our volunteer. Stick your nose in and tell us.
Oh yeah, it smells bad.
Yeah, that's swimming pool chlorine, okay? We can't really tell which electrode it's coming from though, can we? But we can deduce that from our knowledge. So we'll do that after, okay? Alright, so that's effectively now electrolyzing copper chloride, okay? So I'm going to switch that one off. I'm just going to stop the camera for a bit. Right, so this time we've got copper sulfate solution inside this setup. The two outside electrodes are going to be connected to the black terminal. Okay, so that's negative, and the two inside electrodes are going to be connected to the inside one, the middle terminal. Okay. The one in middle one, yeah. Okay, so looking at this diagram, the outside one here and the outside one on the other side, they're both connected to the black terminal. Okay, and the middle one is connected to the red terminal. Okay, so we switch that on, leave it for a bit. Okay, we're not expecting, I don't think we're expecting to see any gas this time, however. What we're expecting to see is what was in the diagram on the question sheet that we did yesterday and Wednesday. Okay, so it was for the purification of copper.
So this will get gold.
No, this won't get gold because this is not impure copper that's come straight out of a mine. Yeah. This is purified copper that we've bought and made into electrodes. If it was mined copper, one of the first processes they do at the mining places, they melt it, okay, without trying to purify it. They melt it so they can form it into blocks. Okay, when they're formed into blocks, then they electrolyse it and go through that process to produce pure copper.
Sir?
Yeah.
Do you need higher current or higher voltage for this to be quicker?
Bit of both, really. It's a combination of both, yeah. Okay, so I'm not going to leave that one for too long. Okay, I'll just switch that off and we'll take her out and have a look. Okay, and if you look at that and the middle one, I think you can see that there's some evidence of new copper forming on the outside electrodes. Okay, and you can't really see the inside one. It's not very clear, but the inside one has lost a little bit of copper, I think. That's what I think, anyway. Does that match up with our observations from our sheet yesterday? Okay, the outside electrode, which was negative, okay, is getting copper plated on it because the cations, Cu2 plus, are migrating there, okay, and they are being reduced to copper metal, so the copper metal forms on that. So if we wanted to plate a metal object, on this one we'd use it as the outside terminal. Okay, so that's copper sulfate solution but with copper electrodes. So the net result is one electrode. The positive electrode gets smaller, the negative electrodes get bigger. Okay, so if you were trying to get pure copper, you'd make the negative electrode the one you're trying to make into pure copper. So your impure one would be your central positive one. So in the mining and purification process. Questions on that one? Okay. Right. This is electrolyzing potassium iodide. Okay. This potassium iodide solution's got a slight yellow colour because a little bit it's already formed iodine from aerial reaction with the air, sitting over on the side bench over there. But it's about 0.05 moles per litre solution of potassium iodide. The possible products would be potassium metal and iodine solution. However, potassium metal cannot form where there is water present. All right, so we might get something else at that electrode, but we'd expect to see iodine forming at which electrode? The iodide ions will be attracted to which electrode? The positive electrode. In that case, this is the left-hand one, okay? So we might expect to see a brown colour produced around that electrode. Okay? At the moment we're getting gases produced at both. And a little bit of brown colour produced there. The thing about this electrolysis process is if you put any ionic substance in a dilute form into water, it's just like electrolyzing water, just like the Hoffman voltameter. It's when you increase the concentration that you get changes like this one here. So the brown colour forming around the left-hand electrode is iodine. It's going directly into solution. That's why we're getting a brown solution. We could verify it by dropping some starch and then we get a blue-black colour. Okay, we're getting a gas produced, however, at the other electrode, quite vigorously bubbling. Okay, you can't quite see it because that little thing's in the road, but you can see the effect of the bubbles near the surface, all right? So that's the electrolysis of potassium iodide solution. Okay, so we've seen 3. Copper sulfate with carbon electrodes. So 4, sorry. Copper sulfate with carbon electrodes. Copper sulfate plus sodium chloride with carbon electrodes. Copper sulfate with copper electrodes. And potassium iodide with carbon electrodes. So I'd like you to draw 4 little pictures of those, perhaps on the back of that sheet that I gave you the other day. Okay, the one with all examples on. And I want you to try and work out the equations for those, as well as finish the questions on pages that I just gave you.